I will be starting soon as the setup finishes, probably faster this time, and we'll continue along with what we discussed from the last time. This broadcast has been started, and I am beginning our discussion, continuing our discussion. So we are going live on multiple social channels as well as our main site, where you can see what I'm doing and even participate if you are on the main website, which is cloudgenius.app. You can also see these streams going on various channels on social media. And let us continue. So I think I am testing one last thing before I begin. I think I'm getting alerts and messages that this is working okay. So let us begin. Yeah, here we go. So yes, I see people are online already. Okay, nice. Good to see you guys. And I am going to continue our discussion from the last time. And so here we go. I'm going to disable this timer business, that the timer you see on my face. I'll get rid of it and start our chat application, which should allow me to see your chat communications. And there is my bot welcoming me. So I said, okay, bot, bye bye. But that's where you get to chat. You can see what I'm doing. You can even see my desktop. You can see my face. And today there is a new thing, which is kind of funny. But here it is. Let's see if I can show it to you. I can write on my face. Yes, writing right on the face. That's by the way, this is very simple to accomplish. This is like look exotic, and I can erase the handwriting. This is very simple to accomplish. It's just a screen on my desk. It is like a display, and it is green colored. So I'm writing with this pen on the screen here, and I am basically eliminating the green color and superimposing on top of this camera, and that's what you're looking at. It's very simple to accomplish. Many people actually ask me these questions about how do you actually stream. So it's it is simple tricks. This is called chroma key editing, and so it is very easy to accomplish. This method of writing on a blackboard or whiteboard, whatever you call it, and this method of just printing right on my face. This is just, I think the last time people asked this question about how do you do it. So if you want to see more, I can actually show you. Let's see if I can show you the other view. The other view should be from that camera there. That should show you like my display right there. So this is where I'm writing. It is green colored, and I write on top, and then I erase it. That's it. That's the green screen. I mean, people think of green screen as something behind me, like behind my body, and that's another way of green screening, where you cut out everything else outside of you, and that can be superimposed on something else. That is another type of green screen. This is like a simple to accomplish green screen method, like I just showed you. So basically, yeah, write whatever you want. This is transient writing, and then this is persistent. So this stays, persistent. And I can, these are my notes. So I can, you've probably seen PDF files generated out of this handwriting, and that show up on the website as we begin. As you log in, you will be able to see these PDF files. Sometimes people want to see what I wrote. So that's what I write on the screen, and this is the transient writing. So having discussed this, let us now focus on the topic at hand today, and that is virtual private cloud. We discussed some of the concepts last time, and here is the cloud I will be using. This is Amazon Cloud, and I will be using the VPC section here. So how do you go there? You go to all services and then search VPC. So VPC, and there it is. So here, that VPC button, you click through and you reach this wizard. Don't use it. In fact, remember this. I want you to not use anything that is readily given to you, pre-configured, and just spoon fed. Don't ever use those spoon fed things. They are pathetic. Never use that. So no to these things. Like no wizardry. Everything by hand. Everything that you know you do the way you want. That is the right approach to understanding, because once you understand these things, you know what to do with it, and you know how to accomplish whatever else you may want in the future. So that's the underlying idea. I want you to remember that. Never ever, any cloud, never ever use whatever is handed off to you, like, you know, spoon fed. Don't take that. So now let's begin. I will begin by drawing out what I want to accomplish in our context of understanding what is a virtual private cloud. So here I go, describing a VPC, and I compared the last time. This thing, a virtual private cloud, is kind of sort of like your private home. That's one way to think about it. Home can be simple. A virtual private cloud, nicely designed, can be highly sophisticated, but we'll begin simple implementations of something that you might have in a typical home and expand it to make it more suitable for a business application. So we'll do that. So in a classic home, you typically have a network where you have some kind of internet connectivity coming from my new favorite, Starlink. This is Elon's what do you call this thing? Satellite internet service, right? That's Elon Baba. And so let me get to my desk pad, and then my video should pop up in the little corner there. You know, actually this is how I should say, because that corner itself is showing my face. So that what you're now looking at is some kind of internet service coming to you either from Comcast, Quest, or any other company. Just Wave Broadband, they give you internet service through their methods. They give you a modem, and this modem gives you public IP. That IP address, the internet service gets an IP address right there. That is the public IP address. In your typical home, you can find your IP address by visiting, actually just Google query, what is my IP? That's the answer. You will get the answer. I am not exposing my IP to the public internet right now, but that's the way you can find out your public IP. And then here you connect your router. This router is typically multiple things inside one box. That's what is called a router. The multiple things include network address translation, firewall, DHCP, and bunch of other services that may be or may not be available to you from your box, otherwise known as a router. Router is also called router in some accents. So that device is what you need, that protects whatever is inside here in your home. Even router is in your home, but router has two legs. One is a private side and the other leg is a public side. So the public side is connected to the modem from any of the internet companies. So that's the design layout. We begin creating that. We'll also have some, you know, allocation of address space. So last time, if you remember, we talked about private addresses. Addresses are defined by RFC 1918. This is request for comments. Internet Engineering Task Force. They have this document. Look it up, Wikipedia, you will find it. That defines a range of addresses assigned for private use. Those are 192.168. whatever you want, and that whatever is limited to these numbers 0 through 255. You can pick any number you want as long as it fits these values. One of these values goes in the box. And another range is, I always forget that. Let me just Google. And the range is RFC 1918. So that's the RFC. In here you will find the addresses, or the ranges are written down somewhere. And it's always hard to, RFCs are always challenging to hunt down the exact thing you're looking for. There it is. So these are the addresses, 172.16.00 through 172.31.255.255. So that's the address range. 170, what was that? 172.16 something something, and some parts of these numbers are also variable, and these values can be anywhere between 0 to 255. There is another range of addresses available. It's called 10 dot anything that you want, and these three ranges are pretty huge, and that's where you can fit your home or private area, private subnet, private cloud, private whatever you want inside these address spaces. So now everything else outside basically is represented by box.box.box.box that excludes these addresses. So these to be excluded as private. Anything else that you can fit in these four boxes with these numbers are considered public addresses, like anything on the internet. That's the public internet address, and that's what you're looking at here when you see the public IP. That IP address is assigned to you by the internet service company, and that will something be something like 102.35. I'm making stuff up. That number. It could be an address. I don't know which country or which ISP will give you such address, but that is one such example address that can be your public IP. And then you can make internal addresses whatever you want, as long as it fits this RFC specification. That means it fits this address space ranges, so you can choose whatever you want. So we'll have to choose our address spaces in our private cloud, like here in Amazon. So we'll begin by creating a VPC like that, and we'll call it Cloud Genius, and that address space we have to allocate. And so my plan is to choose whatever I want, and I would like to have a big giant VPC. The biggest VPC we can possibly get in any cloud, for example, will be something like 10 dot, and that will give you about 16 million addresses in that private range. However, this company Amazon doesn't allow you that big. Google Cloud and other clouds do. This company doesn't. They have a limitation, and so I don't know what limitation is, but they don't let you make that big of a VPC address space. So you have to narrow it down to 10 dot some number, some specific number. I'll pick 0, and then whatever and whatever. So that is smaller in terms of, it is smaller size address space that you will be allowed. So this notation is written as 10.0.0.0/8, and this notation is written as 10.0.0.0/16. If you remember my prior discussion on CIDR, classless internet domain something, CIDR, look up Wikipedia, you will find it, or read listen to the previous session, you will find what that means. But the bottom line is we have to choose an address space, and if you try to put in a big number like 10.0.0.0/8, it will refuse. Let's go do that. So 10.0.0.0/8, and it will complain, say too big, cannot deal with it. Amazon cannot handle it apparently, and so we'll go and say create, and it will fail. It says you have to use a /16 or a /28 netmask, somewhere in between that. So we'll say okay, go with /16. That's the biggest you can get in Amazon. So we'll go with that. Create. VPC gets created with nothing inside, like absolutely nothing. You can see that there are no subnets for our VPC. So these are all for a default VPC. You have a VPC created called default given to you, and now we have created one more, which is called the Cloud Genius VPC. If you narrow it down to that one, you will find that there are no subnets, there are no route tables, one given to you by default again. So you will just call it default and not use it. And so there is no gateway assigned. So basically it's an empty VPC. So let us now start to populate our virtual private cloud, our home in the cloud. That's how I would describe it. Our home in this Amazon cloud. And I'm going to stick to the Oregon region for this example. So just so you know, just stick to that for your first attempt. So let's see this VPC that we have. It's called Cloud Genius. That's just the name I chose. It has an address space of what's the address space? Okay, the full VPC address space will be 10.0.0.0.16. That means the addresses inside can range from and so there are about 1 million addresses, roughly, give or take, that many addresses here. And so that's the VPC allocation. This is called Cloud Genius. And so we would like to then configure things inside. So, you know, you remember you have to have a router inside your home. The first thing, you have to have some internet gateway or Starlink or Comcast or Quest internet service coming into your home, and then the router has to be on the public network. Then you have internal machines on the private network. So you have to allocate spaces or address spaces for these areas, the private and the public sub networks, also known as subnets. This is the big network that we have called the VPC. Inside subset of that will be allocated to this, another subset allocated to this, and you can have more such subnets created, any number of them as long as it fits. So that's the idea. So we'll create those now. We'll go and create 2 subnets. One will be private, one will be public. And just by naming them, nothing happens. You have to actually wire them, connect them appropriately to make it work like you intend to. So let's go subnets. We don't have any in our VPC, so we create one. We'll call this to be created in the Cloud Genius VPC. In there, we'll call it public. And then we have to assign a name, or rather a range of addresses. So our idea would be to create this public subnet and this private subnet with a range of 10.0.0 and then whatever, and this private one 10.0.1 and then whatever. That's the allocation I want to assign to these 2 ranges for public and private. That's my idea. So I want to implement my idea. I will rewrite this in form of the CIDR notation. It is written like this. And if you are confused about this CIDR notation, you should do a read on Wikipedia. And this will be written as 10.0.10/24. So that's the notation for CIDR. And I will create these 2 subnets. Let's do that. Very simple. Here we go, and just type that number. For the public subnet, my intention is to 10.0.0/24, and so I select that. Then I create, and then I create another one. I call it inside the Cloud Genius VPC, and I create 10.0.10/24. That's the idea for the private range of addresses, and I create. Now we have 2 subnets created. You can see them, and they are here in our VPC called Cloud Genius. We filter that, show our 2 subnets please in the Cloud Genius VPC. One of them is called public, the other one is called what is it called? Nothing, no name. Just name it properly then, private, and the public, the 2 subnets. Just by naming them private or public doesn't mean anything whatsoever. You have to wire it, connect, like physically, and not physically, logically, virtually connect these things, like to the router, for example. Yes, like that connection here, router modem. This wiring has to be established. That's how you allocate, and that's how you decide what becomes your public, what becomes your private. And so for each of these subnets to actually become functional, they need to get a table. What's a table? A table is something, basically think of it Excel spreadsheet and table containing data. Yeah, some number here, some things here, something like that. That's a table, right? Table. So this table decides what goes where and how the route, how the traffic will be routed. So the table has lines or rows, and they will decide. That's basically a data entry in some table somewhere. And this route table is called route table, by the way. and that has to be associated with each of these subnets. Another route table associated with this subnet. You have to create these route tables. They're just entries of data defining routes. How will the traffic go to that region, or how will the traffic go to this address? That is what the route table defines. So we'll create two route tables and then associate them with these subnets, and then also connect them. So we'll do that piece. So next, so we'll go to the route tables section and create two route tables right now. Here we go. Route tables. We have a default route table given to us, so I will of course ignore it. That's just how I do it. How I do is I just ignore whatever people tell me to. I don't listen to them. You don't have to. So default and ignore everything. Create your own route tables. How do you create one? Well, you call it a public route table and you put that in your VPC of choice and then create. The table gets created. How does it look like? Here with one entry, destination, local, active. That's it. What this means is that if you want to go anywhere in the destination, if the traffic needs to go to anywhere these addresses, you can just go there locally, like a local connection within the VPC. That's the underlying idea. One line entry right here. That's the entry in a route table given to you. Sorry, you created it. You created this route table, but that is not associated with any subnets yet. So let's make that association of this route table with one of these subnets. We'll have to make that association. We can actually go in this section to make the association. So let's go here and then edit the associations. Right now there are no associations, so we have to edit the association and associate it, actively associate this public route table with the public subnet. So let's do that like that. Here, edit and associate with the public subnet and save. That's it. That's the association established. Now you will see the route table called public route table. Okay, let's filter it again. Filter through the CloudGenius VPC. We have this ignore here, so we'll ignore it. There's a public route table associated explicit. Hold on. Let me filter it again. So go clear CloudGenius, and then we have. Okay, I think my pen is misbehaving. Let me clear that. So let's go see this way. So the public route table is associated, explicitly associated with this subnet, which happens to be our public subnet. So that association has been established. See, the other route tables are not associated explicitly, so we have to do that for our own case. It's our own use case. We'll now create the second route table. So second route table, here we go, route tables, create table, call it private route table, put that in the VPC CloudGenius, and then create it. So we have it now. We have two route tables that are of our interest, so we'll see them where they are. Not this one, not this one. I'm interested in these two, and this one is associated with the public subnet already, so that is done. This one is not associated with any subnet yet, so we have to associate this one with a private subnet that we created. We'll do that next. What I'll do is go to the private RT and edit the association. Subnet association, edit the association and associate this one with the private subnet. Let's do that. So here I go, edit association with the private one and save. So now we have two route tables and they are associated according to what we wanted. So let's recap this idea. This is kind of confusing if you're doing it the first time. So let's go clear it up. We created 2 route tables and associated them with the corresponding subnets. That's all we did right now. This is the public subnet, this is the private subnet. That's the only thing we did up until now. We'll now examine the routes inside the route tables. And so let's do that. Let's go to the public RT and examine the routes. We have one route. The route is allowing anybody to travel to this destination, which is basically the VPC inside. If you remember, the VPC address space is 10.0.0.0.16. So anybody who any packet, any IP packet that wants to travel to any of these destinations, it can just use the local target, a local connection inside the VPC, and that works beautifully. However, what if the packets want to go outside, somewhere on the public internet? Say, for example, somebody inside your VPC home, and this is not a home, but a machine inside your home, or a machine inside your VPC wants to access the CloudGenius website. Well, there is no route to go there, because what's the IP address of CloudGenius? Let's go find out. And so if you go find out the IP address for no, this is not how you do it. So you do ping. Yeah, that's the easiest. So the IP address for CloudGenius is that. What's the IP address? Here. And as you know, this is outside of this destination. It's not within the private area. It is actually in a different cloud. CloudGenius app website is hosted at Google Cloud. And so this IP address is not within this VPC. It's a public internet address. So there is no way to go for a packet using any of these routes in the route table. So we have to create another route. It needs to go out to the internet. So if you want to go CNN.com, FoxNews.com, or some other random news websites, don't go there. They're both bad. And so news are horrible these days. It's a pathetic or nonsense. But apart from that fact, yes, it's a fact. We have to go to the public internet, so that we have to have one more destination listed out here, and that should indicate something like this. That reference that you're looking at, CIDR notation 0000/0 indicates anywhere on the internet. So we have to have a route like this, and a route table entry like this, put it here in the destination list, and it needs to have a method of connecting to the internet. What does that mean? It means we need an entry like this and Comcast. Well, there is no Comcast in Amazon, so we have to find something else. We have to get a Comcast gateway and make it active. That's the entry I want to have in this table. Right now I have only one entry, and I don't have Comcast. So you could fix the Comcast solution, Comcast problem first, get some internet service inside our VPC, and then make an entry like that using that thing. That thing that we need is called a gateway, and we have none of them in our VPC. So if you look at gateways, we have nothing. So we create one, call it Starlink. That doesn't mean that Elon Musk is going to give you a Starlink address, but just my name of choice. So I create that gateway, Starlink. You can see that it is detached. It is not connected to this VPC that I have. So I need to attach it. Action, attach it, please. So action, attach to the VPC. Which one? This one. It's called the CloudGenius VPC. So it picks up and then attaches. So now we have it attached. Nice. The new gateway called Starlink is now attached. Beautiful. It has been assigned this number IGW some number, and that's the gateway attached to the VPC of our choice. So gateway exists. Now we have to create a route table entry. We go to route tables, identify the public one, this one, and then modify the table. How do you modify the table? You go to routes. You see the route there, 10.0.0.16. We need to have one more route. So we edit the routes and say add a route, and say go to anywhere on the internet. So 0.0.0.0/0. And how do you go? Using Starlink. Starlink, that one. How did I reach this point, by the way? I clicked on Internet Gateway, and then I selected Starlink, and then I save. Bang. We now have the wiring between our public subnet through this public route table to this Internet Gateway. That means any machine that you create that sits on the VPC called Cloud Genius, this one, and belongs to the public subnet, which is this one, will be able to connect to the internet because of this route table entry that we now have. It is called the public route table, and it has a route that allows anywhere on the internet 0.0.0.0/0 going through the gateway called Starlink. That's the reason why it will work. So now let's test it. To test something, we need to have a computer inside this VPC, and to have a computer and to be able to connect to it, we need to have a key pair. So in this VPC, we have to go to EC2 to get a machine. Like EC2, that's where you get machines. So we have to go there and find out if you have any instances running. We have none. We have this key pair. It's called Amazon. We'll delete that because I don't have it anymore. So I'm going to delete that key pair, create a new one, give it to Amazon, use that key pair to create a new machine, and put it right at the right spot, which is the public subnet in my new VPC. That's what I want to have, and test it for connection. So that's what I want to be able to do. So what I will do is go to the dashboard, make sure that things are cleared up. We have a default security group given to us, and so let's call it default and not use it. And so next idea is to create a key pair. How do you create a key pair? You go here and say go to the folder called .ssh, and there you might have my amazon.pub. I can see that right there. These two files need to be deleted. I need to create them again apparently, so I'll delete them. Amazon.pub and Amazon. I'll delete both of them. Then I will create a new key pair. The key pair creation is very simple. SSH keygen, and then enter, and name is Amazon, and then no passphrase, done. Now we have a key pair. The key pair is called Amazon, the private key. Amazon.pub is the public key. So we'll copy the public key into our paste buffer, and then we have it in our copy paste buffer. We'll go to Amazon dashboard. In the key pair section, we don't have any key pair, so we add and import a key pair, call it Amazon, and then paste. This is the copy paste that I just did from the public key into the browser window and import. So now I have a public key pair given to Amazon, and I hold the private key right here. Which one? This file. That is with me. It is private, and the public is what I gave to Amazon here. So Amazon knows my public key. I have the private key. Nice. I will use that key to connect to a machine I will be creating in Amazon's EC2 section. Go to the running instances, launch an instance. Here I go create a new computer using Ubuntu OS, and that is your Ubuntu Server 2004. By the way, soon in month of April, I think 21st of April, you will have 2204 showing up here, because that is the new long-term supported version of Ubuntu is going to come out soon, and that is going to be awesome. So I'm waiting for that. Ubuntu LTS long-term support, new release is coming soon. Every 2 years, you should see that. And where is that thing? Open source 2204 date is April 21. That's the date you will receive this new version that is not currently available in release form. It is available in beta or maybe pre-beta. And so that we have to go with this for now. So we'll select that one. We'll put this in T2 micro, very small free tier size. So that's a cheap machine, T2 micro. We'll choose the configuration details. Here we'll choose the CloudGenius VPC. Don't go to the default one. Choose the CloudGenius VPC right there. Then make sure that you put it in the public subnet, not the private one. It's not private, it's not ready yet. Public is ready, so public. Then we have to get an IP address assigned automatically. So we'll say enable please. That's, I think, critical to explain, so I'll explain these ideas. You have to get a new machine. You have to get the machine in your VPC that you want, and you put that in your public subnet. Don't go in the private. And you want to automatically get a public IP, because you want to be able to connect to this. This is like a router, right? It needs to get a public IP. And so this machine that I'm starting up is going to be created in your public subnet, and we'll get an IP address. So I will now go to add some storage to it. So adding some storage, and here it is going to give me GP2, GP3, whatever SSD you like. GP3 is slightly better in performance, but it doesn't matter for our test case. So we'll just choose whatever you feel like. Add some tags, no need to. Configure a security group. Now we don't have any custom created security group, so we will create one for us for right now. We'll do that simply by creating a new security group, and this we'll call this I am testing. You can call it whatever you want. So I'll just call it I am testing public subnet. That's the name of my group. And in here I will allow SSH access, port number 22 from any location on the internet. So this is basically going to let me in to my own machine that I'm creating. So I will call it let me in please. That's the name of this description of this security group, called I am testing public subnet. It's just for a test. We'll create something and review and launch. Now it's going to launch a new computer in our public subnet. If you remember what I'm talking about, is this public subnet right here. I'm going to create a new computer here, and that's what I want to connect from my home. I want to go from here through the gateway and connect to that machine like there, because this is a public subnet and it has a public route table which allows connections to the gateway, and so we can do whatever you want. It's like a public machine on the public internet. That's what we want. So we want to launch this machine, and it says key pair please. So choose a key pair. So I can choose a key pair. I have that one, Amazon. So I'm going to say yes, I acknowledge. I acknowledge that I have access to the corresponding private key file, and I definitely do. I showed it to you right there, this file. And so we have that file already. So we'll select the choice of saying yes, I know what I'm doing, please proceed. I acknowledge that I have the corresponding private key. So yeah, launch new instance, and then launch failed. Oh, Okay, Amazon, why did you fail? It says your request of T2 Micro is not supported in your blah blah availability zone. Try a different zone. Oh, how helpful, Amazon. This is actually dumb. You should allow any size anywhere. Why are you not allowing that size T2 Micro in West 2D? So this topic we haven't discussed about availability zones. We'll discuss that later. But right now I have to, because it is stuck. So back to the review screen and change the availability zone from 2 delta to something like 2 alpha, beta, or Charlie. It is not allowing you to create a T2 micro size machine in 2 delta. So it's forcing you to retry by not specifying availability zone. I did not specify availability zone. You chose it for me and you chose it wrong, Amazon. That is stupid. I did not choose any availability zone. I went with default. They should have chosen it correctly between A, B, and C, but they chose D and they tell me that I chose it wrong. Are you kidding me? No. So bad, Amazon. Let's go back, review. What availability zone did I select? Nothing. Let's go back, previous and previous and previous and previous. And here you see, I did not choose availability zone, did I? Okay, you see, the problem is even more complex than what I thought it should be. The problem is they chose availability zone 2D for public subnet automatically. So we have to now go and create another subnet. That's one way. Another way is to just change the machine size. So instead of saying CPU T2 micro, I just go with a bigger machine. That's the easiest workaround. So I'll go with something like T2 medium. I hope that is available in this D or delta availability zone. So T2 medium, configure. I want to continue with this instance type T2 medium. Yes, correct. And then I am CloudGenius public subnet, enable, add some storage, add some tags, and configure security group. This is the security group I want. It is called I am testing public subnet. It is allowing SSH access, port number 22, and I review in launch, and it says it is not eligible for free tier. I understand that. That's fine. Your instances are open to the world. That I understand. Fine. Now please launch. And here is my private key acknowledgement, and I launch the machine. So please, and it fails again because T2 medium is not supported in 2 delta. Okay, so try a really big size machine now. I hope something is available in that 2D, otherwise I have to create a new public routing table and a new public subnet in a different availability zone. I will do that, but right now let's go modify the machine size. So back to the review screen, edit instance type, and let us go through to select something like a you know what, they should not even show these machines that are not available in your region of choice or whatever availability zone of choice, but they're showing it to you and then failing on you. That is dumb. Okay, some M is a good one. M5 large, it's a decent. M4 large, it's a good size machine. So I hope that is available. Let's go review and launch. So yes, I change it to M4 large. Next. This is an expensive machine, by the way, just so you know. So don't mess with it unless you want to waste your money. Launch and say I acknowledge, and so it's going to launch a new machine, I hope, and it doesn't fail. How dumb is this? No, M4 is not supported in your availability zone 2 delta. Okay, so I think 3 choices. I tried various machine sizes. They're not available in our 2 delta availability zone, so I give up. And I will go back to VPC and create a new subnet in the right I recommend it. It's not wrong, it's just they don't have, apparently this public subnet was created in 2 Delta for some reason without asking me, and I cannot edit. So let's see if it lets you edit the subnets settings. No, it doesn't let you change the subnet selection. So what we'll do is we'll ignore this one also. So we'll say edit the subnet, or just forget this, create a new one, create subnet in this CloudGenius VPC, and then my subnet will be, I need to change my addressing scheme, right? This addressing scheme is for that subnet is occupied, so I'll go with something like 10.0.2.0/24, and I'll call this new public. That's the choice. Excuse me, name choice and subnet selection choice. So I'll go with that. This is called new public, and here, like usual, excuse me, I don't indicate any preference, but this time they are forcing me to consciously select something like 2A. So I'll go with that. They're saying don't go to D. I think this D is new. Amazon in Oregon used to have A, B, and C. They're just introducing something new, and they're not done with their preparations, and they're stupidly selecting it by default and then failing. So let's go with 2A, and then here we'll go select 10.0.2.0/24. That's the choice that I had here, right? Remember this choice, 10.0.2.0, the same thing I chose. And then this is called new public, and then I create, and then I'll create a route table, or I'll just modify my public route table and change the association. So edit the association, and this is associated with the public subnet. I'll modify that and say you deselect this one, please select, save the association. So the association is now corrected. Now I can go and try again. What I'd like to do is go to the Amazon EC2 section and go a little bit faster this time. So now create a new machine, select Amazon Ubuntu server, select machine size T2 micro is good enough, I hope. Review, no, previous, cancel that again. Let's go begin again. Launch, Ubuntu select, T2 micro select, VPC select, public, new public 2A, not 2D, 2A, select, and then enable public IP, and then add some storage. This is good enough. Add some tags, not needed. Configure security group. So choose the one that I wanted to have, which is a new one. Let's call it let me in. That's the name. Description is whatever you like, and the rules allow port number 22 access for SSH protocol, and it says let me in, and that's my security group. So I review and launch, then I say review, and then I launch, and then I choose my Amazon key pair and launch a machine. The machine should start, and apparently it did. So we go look at it, it's pending, and we'll go to the dashboard to see, and we have one machine that is trying to start. It's pending, so we wait for it to actually boot up and then make use of it. So while it boots up, I'm going to play with my new setup that I just created, which is look at that, the camera goes that way. This is funny for me. I don't know if it is funny for you, but that's Nidesh taking a look at all the aspects of Amazon. That's a bad joke. So while it is, oh, it's not running now. Okay, fine. So this running machine, let's go see. Here you, what do you have? A public IP. There we go. We have a public IP, so we can copy it. Now we want to connect to that machine. So how do you do that? Well, your first thing is that you take that public key that you have there, this public key, Amazon public private key pair. You take the private key and put it in your keyring. How do you put that in the keyring? Is by SSH add, and then a reference to that file, the private key file, that adds you your key to the key ring, so you don't have to like pass this key reference every single time you connect. Then you just SSH and type in Ubuntu as the username for the machine that we created, and then put in the IP address, and then you don't have to pass this flag anymore because I added it to the key ring. You don't have to do this. You can, but not needed, because the keyring now knows about this identity in the keyring. So there are lots of keys you can have, and you can have this key and that key and some other keys you might have. You can put them in a keychain or keyring. This is how you add it, so you don't have to type these things over and over again. That's the idea behind this keychain or keyring. So now let's go attempt to connect, and we'll say yes, and it connected. Nice. See, our public subnet worked. Amazon gave me a difficult time by behaving stupid and selecting 2 delta for me. 2 delta was this, what was that? VPC public subnet. This public subnet was in the 2 delta availability zone, and that's a new one apparently coming up, but they're not allowing machine creation that 2 delta. So we have to create this different new public route table. We put that in a availability zone 2A. You can choose A, B or C. Apparently Amazon lets you create machines in A, B and C, but not in D for right now, for some strange, I would argue dumb reason. There is no logical reason why you should have a subnet and not allow people to create machines. I think it's a limitation. Either you don't even allow. So you chose this for me, 2 delta Amazon. You did. Yes, and if you are an Amazon employee looking at this video, call me, because I want to yell at you. Don't be dumb. This is where the reason is, you know, new employees or new customers who are trying to use Amazon. Yeah, this is dumb. Don't do it to people. Okay, so we have that machine running. Nice. We can actually discard that machine, because what I want to actually do there is to put proper router, a NAT, network address translation machine. So we'll go to our Amazon EC2 section and discard that running instance by killing it. So here we go, action, terminate, instance state, terminate, instance state, manage instance state, and then terminate. And this is where you kill the machine. Like, bye bye. So machine is dead. Fine. What I want to do is to put a router there, like in this running instance, which I don't have anymore. It's shutting down. I want to actually launch an instance which is a ready-made router. So what's a router? A router, not this. No, that's a Netgear router. But that's an example of a router. If you want to find out what a router looks like, it looks like this. But you cannot take a router from there and go to Best Buy and say, Amazon, can you put that router in your public subnet, or rather new public subnet? You cannot do that. So what do? You ask Amazon for a ready-made router. Just search for NAT in the community AMI section, and you will find a bunch of NAT devices. That's a good one right there, 2022 February 9. That's a recently updated NAT device. So this is the keyword now. AMZN, AMI, VPC, NAT. What does it mean? It means Amazon machine image, AMI, VPC as in virtual private cloud, NAT as in network address translation, and that machine, if you use this image to create a new computer in your new public subnet, select and go through the same motion, you will get a NAT device mounted at the right spot. That's what we want. By the way, this NAT is nothing magical. It's basically just a Linux machine with like 2 lines of code added to the firewall table, and it does masquerading. And I'll show you in the next exercise. We'll do the whole thing automated. Right now we're doing everything like by grunt. Click this, do that, understand this, understand that, fail, do it again. That's just the manual grunt way. The next, some subsequent session, we'll do the whole thing 1 line command, boom, it sets up the whole thing, machines, configuration, route table, NAT, this, that, gateway, every single thing, and it works. That's the magic of automation. You will see that. But before we jump into automation, we have to do something called wax on, wax off. If you haven't seen the movie, you should. That's what I'm doing right now. Is Miyagi asking this dude, Karate Kid, wax on, wax off. Do the whole thing by hand until you understand, and then automate. Automation is easy. Understanding is the hard part. So do that. Wax on, wax off. Unless you get it truly by hand, by actually failing multiple times, you will never truly understand. So my goal is to make sure that we understand everything. And so that's the machine image I'm going to select. Next exercise, we'll do this with a regular Ubuntu machine and add some 2 lines of code to make that Ubuntu machine convert into a NAT. But for right now, select this NAT machine, T2 Micro. Next, I want to configure this in the CloudGenius VPC, put that in the new public, not the old public. Old public is dumb, it doesn't let you create machines for some reason, and definitely get a public IP address, so enable it. So now we have chosen the CloudGenius VPC in the new public subnet, enable to get a public IP. We want our router to get a public IP, right? If you remember this, the router that you get from outside, a router needs to connect to a modem. The modem gives you a public IP. The modem is like internet gateway in the case of Amazon, for example. And this is the public IP. You need to get a public IP here. So whatever machine you're creating, it has to be on the public subnet, new public, let's call it, and it needs to get a public IP. That's what I'm selecting here. Automatically assign a public IP, enable please. So with that, we add some storage, very minimal. GPT-3, good enough. Add some tags, not necessary. Configure security groups. I'll create a new one. I'll call this network address translation. Network address translation. And this is, again, I'll keep it simple, minimal. Allow access from anywhere on the internet to port number 22, SSH access, review and launch, and then launch the machine and launch. So machine launches. This is going to be my NAT, and it takes a few minutes for it to pop up, and it should pop up any moment. And what does that do is create a NAT machine for us in our new public route table, new public, and that's where we are creating a NAT box. We are getting a public IP address, and we are waiting for it to kickstart. We have a idea about creating a private subnet. We are not there yet. We have the subnet, no route table, so thing don't work. Let's get the NAT thing going first, and then, like in a typical home, what you want to be able to do is, in a private area, you have your PC, your Mac, your iPhone. All these devices will be on the private side, and they need to connect through your NAT. They don't go straight to the modem. Don't do that. Go through the NAT. That's the underlying idea, right? That's what we are going to implement. We'll get here soon, but let us make sure that we can connect to the NAT. So let's do that. Here is our browser, and in the browser you will see that this machine should be running now. There we go, and that is your NAT machine. So we'll call it our NAT, network address translation machine. It has an IP address, public IP. Beautiful. So now I want to connect to it just like the item before, except the IP address is different, and this will not work. Why would it not work? Sorry, SSH Ubuntu at this IP address, this method will not work at all because the username is wrong. How do I know? I know because we didn't do a Google search about the Amazon machine image user for Amazon Linux. So the keyword to search for is user for Amazon Linux. What's the user? So the answer is, it didn't give you answer. Oh, there it is. The answer is right there, EC2-user. That's the username needed. You cannot use the name Ubuntu for a Amazon Linux box. This NAT that we are getting here, this NAT is an Amazon Linux computer. You can even see that name defined somewhere here. It says Amazon Linux. It is not Ubuntu Linux. So for Ubuntu Linux, the name is Ubuntu. But for Amazon Linux, the name is right there. And to be able to get more precise answers from Google searches, you should ask something like, what is the username for Amazon Linux? That should give you more precise answer right there. EC2-user. So that's the name. You have to use this name and then followed by @ symbol and the IP address to connect to it. So let us do that. So here we go, SSH EC2-user at the IP address for the NAT box, and then bang, and I connected. Beautiful. So I am on the NAT machine, and that's a good thing. Now I can exit from here and now go to the next idea. The next idea is like this. I want to now have a private area. In here I would like to create a new machine, and that machine should be able to connect to the internet, but without connecting to the modem. That is not what I want to do. I want to go through the router. Now that we have a router, yeah, get this connected to the router. How do you connect that? That's where the route table comes into play. You see that route table here in Amazon VPC route table called private route table. This one is associated with the, by the way, just so you know, we have to create a new subnet for the private side also. This is stupid of Amazon to give me, they also gave me West 2 Delta in the private side, and we'll run into the same issue. So we have to create a new private subnet. So subnet, create subnet. Let's go select the CloudGenius VPC, and then here let's new public. Like new public, we'll create a 10.0.3.0/24 and call this the new private. So that's a new private subnet I need to create, and make sure that I don't go to that Delta 2 Delta, whatever that they had. So this will be the new private. It will be in 2A, not 2 Delta. Don't select that. Apparently they are not ready yet. They're showing it here, but that is not ready. They don't let you create machines in that. Why show it here, dear Amazon? Don't show it if you're not ready. So now we'll select 10.0.3.0/24. That's what we chose here, 10.0.3.0/24. So that's the number that I selected. I will go and label it new private, and I create the subnet. I'll go to my associations in the route tables and change the private route table, change the association, edit association, and remove the private, put in new private, and then save. That association is corrected. Now I need to take a look at our route tables one more time. Look at our private route table. The association is corrected. It now goes to the new private. This is the private route table. So association is correct, explicitly marked associated, but our rules are still limiting. Let's see what that means. The rules are limited in that they don't allow you to go anywhere you feel like on the internet, because that rule doesn't exist. So we need to create that rule, or rather create that entry in the route table. That's an entry. This is one entry, this is another. We don't have the second entry yet. We need to create that entry. So we'll edit our routes and say add another route, let it go anywhere on the internet, and here we choose. Now what do we choose here? We have to choose our NAT. So you remember this discussion? Where is that? I told you to not go to the gateway directly. That same idea. This machine should not go to the internet directly, but go through the router. That's exactly what you do in your homes. Not like this. Go through the router. So this association between this route table for the new private has to go through route table to go anywhere on the internet. The 0000/0 basically means the entire internet. So you want to go anywhere on the internet, you need to go through the router. You have to create a route table entry right now, right here, and we have to choose our instance. See that instance? So you have to select that instance. Which instance? The NAT instance. See how I did that? Do it again. Instance. See this route? I'm going to go anywhere on the internet, choosing the instance, and then as soon as you select the instance, the next thing pops up, which is instance, and then the instances that you have, which is NAT, that machine that we created. That is the way you wire things up for the edit the route tables and then save changes for the route table called private route table to allow traffic to go through this NAT machine, the NAT instance. That's what I want to save. So I saved it. So now our route tables for the private route has 2 entries. Let's go see them. Here we are. So anywhere within the VPC, local connection, anywhere outside on the internet, use the NAT machine. That is how you should wire. However, there's one last step that needs to be done before this NAT machine. This router will not function like a router unless you do one critical thing. That thing I have to describe it to you. It is kind of esoteric and it is something very important, but that idea is called masquerading. A router or a NAT device is a masquerading device. It basically lies. How does it lie? Let's go describe that. So in your home you have a PC that connects to the router or a NAT device. Let's call it NAT. And the NAT is connected to your modem, and the modem is connected to some internet service. Now this PC, you want to visit CloudGenius website. .app. You want to go there. So the PC opens up a browser and says, go to this website. And in your home, the way to connect is to go through the NAT. So the NAT device says, this PC wants to go to this website, let me help. And so NAT takes over that request and sends that request out to the internet wherever this thing is running, and says, I need to see what you have. So request goes in. And by the way, while this NAT sends that request, this NAT, it lies. What's the lie here? It says, I am the PC. No, you're not. This is the PC. The NAT blatantly lies. It says, I am the PC and I need to see this website. So this CloudGenius website will respond back. And the response will be sent to the NAT, because it says, I am the PC. So the CloudGenius site says, hey PC, here's my response. And so this NAT device receives the response, but it needs to hand off that request, that response back to this PC which originated the original request. This response needs to go here. And this liar is basically lying. And what is lying about? Is telling other things on the internet that it is what the requester is. I mean, I'm the PC, or I'm the iPhone, or whatever you have inside your home. It lies. And so the response that is reaching the NAT device is not destined for the NAT, but is destined for this or something else in your home, like an iPhone, for example. So you open the iPhone and open a browser and try a CloudGenius app. It goes to the NAT. The NAT says, I am the iPhone. CloudGenius responds. The NAT says, I need to send this traffic out to this phone, not to the PC this time. And that's how it keeps track of who originated the request. It lies and then gets the response back, and the response gets handed off to the requester. So this handing off action basically means that we have to masquerade as somebody else inside the private area, and the response reaching the NAT is not destined for the NAT. The destination happens to be something else. So that's the key idea to remember. Now I'll demonstrate this actually in action. So we go back here in Amazon EC2 section, look at our machine, which is the NAT machine right there. Now this machine, you have to go, and this is kind of clumsy to find. So here it is, instance state, the action, networking, change source destination. See that idea? That's the idea here about change source destination check. And we have to actually disable that check. So let's do that. And let's go see that what it says in Amazon. So this is kind of helpful of Amazon to describe this idea. In this blue box, you have to read the blue box carefully. We are dealing with a NAT, and we are going to disable the checking of source and destination, because the packet reaching the NAT is not destined for the NAT, but it's going to go to the iPhone inside, right? So the source and destination do not match. A response coming in, request came from here, so it has to be passed on. That means the source and destination checking on a NAT instance must be able to send and receive traffic when the source and destination is not itself. This is the source, and the destination is also that same phone. It is not the NAT which is going to open up the CloudGenius website. What does that mean? Read this one more time. A NAT instance must be able to send and receive traffic when the source and destination, source or destination, is not itself. So you have to disable this check. So we disable that, and this should be done only for a NAT machine. Only. No other machine needs this feature. So we'll go and stop the source destination checks. Now suddenly our NAT machine is behaving like a router. Now we can create new devices inside our private, or rather new private subnet. Let's go see that. We'll create a new machine inside, launch, instance, create a Linux machine. So we'll go Ubuntu server right there, Ubuntu server 2004, select. This machine I want to have T2 micro is good enough size. So I choose the machine to be in my CloudGenius VPC. And this time I want this to be in the new private C2A, not the 2D. 2D is broken. 2A, new private. And here I don't want to get a public IP at all, like none at all. So I will make sure that this is disabled. So you will ask me this question about, hey, if you don't have a public IP, how will you connect to this Ubuntu machine inside in your private, a new private area? New private, this Ubuntu machine you have there. You are in the public side, or the new public side. You have this NAT machine, and you are able to connect it from your home, and that's all good. And you connected, and that's fine. But here you want to create a new private machine in the private subnet, and this will not have a public IP. You see that? Disable. So then how will you connect to it? There is no route. So we'll have to discuss that separately. It's a separate topic about connections, but for right now, make sure that we are choosing the VPC, choosing the new private subnet, and not getting a public IP. So that's the key choices to be made here. Let's go forward. We add some storage. Minimal storage is good enough. Add tags, not necessary. Configure security groups. And this one, I will create a new one. I'll call this, what do you call this? My boxes, my private boxes. You can call it whatever you want. Doesn't matter. Private machines. Or you can run your applications there. On the internal machines, you can run applications, and so they are running inside behind your NAT. And then here you want to just, allow SSH access, and you want to allow SSH access from the NAT. So SSH access originating from your NAT. I think I called it let me in. I should have called it NAT, but I'll create one more. So we'll do this security group piece just a moment later. I'll just begin with my applications. This is for my applications. I review and I launch this machine, and it gets started. Now let's go review the security groups idea. So we'll go to EC2 and look at our security groups. We have a bunch of them. We'll ignore most of them. And this one, I think I'm testing public, is what I used when I failed on the 2 delta sub availability group. So I'll probably delete that. So let me just delete that security group. It's not necessary. So we delete security group called I am testing public. Go bye bye. That goes away. Then we have to filter in our VPC and make sure that we are removing clutter. So there's a lot of clutter here apparently. So this let me in whatever is not properly named. So let us see if we are using this one. Let's go delete that one. If we don't have it, so we will get rid of it. So this VPC, I want to, this let me in group, I want to get rid of. See if I can get rid of it. Probably yes. So I cleaned out. The default I don't use. This allow inbound is I think a spurious one for some previous other VPCs, not the CloudGenius VPC, it's some other VPC. I'm going to get rid of it for now. So I delete the security group and say goodbye. Some cutting clutter. This one is the NAT security group that I want, so I call it NAT. This one is for my applications, so I'll call it my applications. Nice. And the two defaults, I cannot delete them. They're just not deletable. They cannot be deleted. So don't delete them because you cannot. So ignore them basically. So ignore this, ignore that. Now we have two. One for the NAT device. There is a security group that allows you to access that NAT machine from anywhere on the internet, IPv4, and that's your rule for inbound access, and that is awesome. And for outbound access, it goes anywhere you want, all traffic allowed. Nice. Inbound rules, IPv4, SSH, TCP protocol. So I want to make sure that our machine for NAT is using this security group, which is the number 706E. So let's go check that whether the NAT machine is using this security group. We'll go and cross check. Instances, there are two of them. One of them is called the NAT machine, and this one is called application server inside the private area, new private area, and this is a dead machine. Dead. It's terminated. The dead body will disappear in about an hour from death. So we ignore that. We have these two machines, the NAT machine, and let us check whether this NAT machine uses the correct security group that ends in 706E. So let's go check that. In our security section, we should have a reference to the security group used. I'm going to cross check that and make sure the rules are properly configured, because without that we cannot make sure that things will work. So security and security group is the correct one, 706 echo. That's a NAT security group. That's correctly established. So here we have our inbound rules. Let's go check inbound rules, and it allows for access to anywhere on the internet, and SSH access, save rule. That is, we have not made any changes. Fine, that's good. So that's the security group for NAT. Let us see the security group for applications. In this application security group, we have inbound rules allowing access from, let's go edit the rules, allowing access from anywhere on the internet. Fine. Plus we have to allow one more rule to get SSH access coming from the NAT security group, and then allow access from the NAT. So that's what I'm doing. I'm getting permissions for accessing from the NAT to the machine inside, and I save. That's the change I just made for security groups, and so we'll have a separate discussion on security groups later on, but for summary right now we have two security groups. Let's go see that. One group that addresses access to the NAT, and another group that allows access to the application servers. And the security group idea is basically a set of rules that will allow you to travel through on a highway. And so there are two aspects to it. One aspect is to be able to is there a road? Is there a road? The second is, do you have a license? Can you drive? So those are two separate things, right? Is there a road that exists? A road is like, is there a route that you can take? And do you have a license? That condition check is about security groups. Do you have a license to drive on that road? Even though the road might exist, you still cannot drive because you don't have a license. So this is how you can think about routing versus permissions. The security group is about this idea. Do you have a license? So the license that we have given to ourselves in the NAT security group allows for access from anywhere on the internet So my home, for example, can connect to the NAT box because the security group does allow connections, inbound rules. Let's cross check that. Inbound rules for security group for the NAT. Inbound rules allow anywhere connections anywhere on IPv4. Let's go cross check that. See that 0000 shows you that anywhere on the internet any IP address can originate and will be allowed to connect through port number 22 in the SSH protocol, provided they have the private key. That's the inbound rule for NAT. Let's go see the other rule that we have created for this. And the rule for inbound, I have two entries. One, anywhere on the internet can connect and reach this if you can, but there is no route. The second rule that I created is to allow this NAT machine to connect, and so allow from NAT. And let's go see these two rules in the inbound rules section of the application security group. Cross check that. So we'll go and go to the security group section, go to the application section. This is the area where most people get confused and they reach out to me on chat or Zoom. So pay attention to this idea. This is critical to understand. If you don't get it, you will struggle, you know, and that will be fun. Yeah, struggle is fun. And so you will struggle, but just pay attention right now. Here, applications. Two rules. Edit the rules. First one, allow for anywhere on the internet, any machine anywhere on the internet to come in through port number 22 with the SSH protocol. But you know, in our applications section, there is no route. There is no road to drive a car on. Even though you have a permission, there is no road. This rule is kind of futile, but we keep it. We understand. The second rule is a reference to anything that is originating from the NAT security group. If you originate from NAT, well, then you come through this port on that protocol, you are allowed. The two rules here for the applications security group. That piece is understood. Now we can use that. Let us see how we can use it. So in our application machine that we have, this machine here, which security group is it using? Let's go cross check that, and you can see that it's using the applications security group right there, which has two rules. The rules are written down right here. Allow anywhere access from anywhere on the internet, but there is no route, so allow access from the NAT security group, and that is the one that will actually be put to use. We'll actually use the NAT as a stepping stone to get inside our machine, internal machine, and you will see that soon. So now we have this machine. It has a empty public IP address, no public IP. You cannot even, it's not reachable, it's not routable. All we have is this private address 10.0.3.74. You can compare that with this subnet choice that I made before. See, 10.0.3.74 right there. That's a new machine, got an IP address right in that spot in the private space. Having seen that, let us attempt to connect to that, and it will fail, because if you try SSH Ubuntu at private address, it will fail. It has no idea where that address actually is, because it thinks it's a local address in my home. But no, my home subnet is not that 10.0, it is something else. So it cannot reach, so it's not reachable, not routable, so you have failure. It will just hang like this, do nothing, and then fail after like a minute or so, whatever the timeout value is. So you break it. It's not going to work like that. So what do? We hop. How do you hop? You go through that IP address for the NAT machine inside here. That address, we know that, and we can connect to it like this, right? So we already connected, it succeeded. So here we can actually reach out to the machine inside. Can we ping it? 10.03.74. It's not pingable. Why? Because we haven't allowed for pings. So how do you allow for pings? You go to the dashboard, go to the security group section here, and for that application security group, you modify its inbound rules and add another rule. This time, for the ping to work, we need to allow ICMP protocol. And so ICMP protocol is written somewhere here. Just type ICMP, and there it is, all ICMP. So there we go, and you allow it from your NAT security group. So you select that, and then you save the rule that basically allows for pinging, and you should see some pinging happening. There we go, ping succeeds now, because the security group allows for ping now. So we did not choose to begin with, that's why it was not allowed. So pinging from the NAT to the machine inside seems to work. Nice. What does that do? Well, we have we have this machine inside called NAT. We connected there, and from my home I am here logically, and then on the private side, on this address 10.03.74, there's this applications machine, and I am able to ping it. Yes, I can potentially even connect to it, provided I have my private key. My private key is sitting on my laptop here, my whatever that machine that I'm using is not a laptop, on the Macintosh. That's where the private key is, and it is supposed to be private. See that? That key is in this folder. It is this file called Amazon, and that is a private key, and it needs to be private no matter what. That means I cannot just randomly give it to other people or even other machines. That means this private key that I have in my possession, in my custody, in my home, on the Mac, in that folder /.ssh, that private key called Amazon should not be given out, period, end of story. But I need that on the NAT box. But I told you that don't give it to anything else outside your possession. So you can copy this key and put it here, and then use that key to connect to the machine inside. New private. That is doable, but it's a security risk that this key goes out of your possession into the cloud. Bad idea. So then how do you connect to this machine? If you're telling me that, you know, Nilesh cannot move this key, but I still want to connect to it, so what's the workaround? That's the thing that we'll discuss now. So that thing is called SSH configuration proxy command. What we are really doing essentially is using that NAT machine to connect to the machine inside. We are using this as a stepping stone. We'll connect to here, and then through proxy command reach here, and that is given in this example. I'll read that example out. I'll describe it, and I'll edit that file in a manner that allows us to use this use this internal machine as a stepping stone to get the machines inside in the private area. To get there is what I want to accomplish. So let's go see this config example idea. What is it? So we'll config example, read it out. So fairly detailed content here. I'm going to read that out carefully. and I'll narrow it down to something very simple, very simple for us to use. So I will copy these things first. I'll just open it up in editor, that's easier, and then clean it up. So there we go, open it up, see what opens up. And I'm going to clean up this long file and get to a point where it is really distilled and usable. So this is what it looks like, or what it should look like. I cleaned it up. Let's make it bigger. Okay, and we'll modify these things a little bit. So we'll call it the NAT machine, and then we'll set the correct IP address for the NAT. So this is not the right address. So what's the address? We copy it from our dashboard, go to the running instances, get the NAT machine's IP address copied over and paste. Then the identity file is not called IDRSA, but it's called Amazon in my context, so I change it to that. Then we have the machine inside is called 10.03.74 or whatever, something like that. Instances go inside to the machines that we have, and the machine has an IP address of 10.03.74, so that I have it correct. Next, I think this is good. So that's how the configuration should be written. So we'll save this file as is, and then copy this SSH configuration, config example, and modify the file called config. So there's a file called config already there. That's my existing configuration right there. So I'll delete that for now, and then use this content here in that file. What does that mean? It means something like this. I'll remove the file called config, it's gone. We'll create a copy of the config example and call it config. That's it. So what do we have now? There's no difference between config example and config. Absolutely no difference. The same thing, diff config and config.example is null. There is no difference in the two files. They're copied, right? So that's how the configuration should look like. And now one more thing. You know this file from a previous example called known hosts, previous session, some session. So I described this idea. I'm going to remove those files called known hosts, and this and this and all the known host files. I'm going to get rid of them. They're gone. So now we have a config file, that's how it looks like, and a private key and the public key. Public key is with Amazon, right? You already understand that piece. So the key idea here would be to attempt to connect to the NAT machine as described here. How do you connect? This time it's a whole lot simpler. You can just say SSH NAT, and it says, are you sure? I say yes, and it connects. You connect it to the NAT machine. Nice. Exit. Now when we do this, what happens is when we say yes, answer yes here, it generates a known host configuration that looks like this. And so it puts these entries for the machine that you just attempted to connect, which is the NAT machine, and you have these entries. So now next time when you say SSH NAT, it just connects. There it is. And then you exit. and connect again, and then you exit. That's the idea. That's one. We reach the NAT. Now we have to go to the machine inside. Now in our SSH configuration, we know that we have this host here, 10.0.3.74. We want to get to that machine, so we can just say SSH 10.0.3.74. And earlier, without this configuration in place, it was not routable, but now it is routable. Why? Because it knows about the existence of this address in the SSH configuration, and it is able to jump through the proxy command right there. This line is the critical line. What it does is, when you try to access this machine IP address like this, it will say, let me go use the NAT box as a stepping stone and use the proxy command SSH, pass my identity file reference from the keychain, and go inside through the NAT and then jump onto this, and therefore this will succeed. So we'll go hit enter, and it says yes, and then we are inside the machine called Ubuntu, and that's where we reached. So now let us exit and do this again. What do I want to do? I want to get rid of the known host files again one more time. So now you see I deleted the known host files. I will now attempt to connect to this machine one more time. Let's see what happens. So attempt. First question, are you sure what you're doing? It says, are you attempting to connect to this address? But we attempted to connect to this address, so are you going to the right spot? Am I? Yes. Why? Because the configuration says that you want to go here, you have to go through the NAT, and this happens to be the NAT address, as you know. So it says, are you sure? And I'll say yes, and then I'll say yes, and that says another question, are you sure you want to connect to this new box? This new box is 10.0.3.74. And I said, exactly right, that's where I wanted to actually go to begin with, but you took me here to the NAT, because that's the proxy command jump hop, like one step jump through the NAT to the machine inside, and then we'll say yes, and then it connects to the Ubuntu machine. So this machine is Ubuntu right here, right now. This machine is Ubuntu, and we are able to reach and operate on that machine, if you like, sitting from my home without actually giving out my private key. This private key is still private, it's with me. I did not give it to the NAT machine, but I is able to traverse through the NAT to get to the machine internal inside. Now let us see, back to the security groups idea. I want to be able to have that applications machine inside in the internal area here, this machine, this IP address 10.0.0.74, 10.0.3.74, that machine. I want to be able to get that machine out to the internet, but not directly through the NAT. The wiring is already like that, it goes through the NAT, that is true. But let's check the security groups for outbound rules. Security group for this machine called application server, the security group is this one, and it has inbound routes that allow for whatever we saw before, but the outbound rules do not allow what we want. We also would like to modify, and I'll describe this concept a little bit on a piece of paper before I jump into the details. So the idea is like this. You have a machine here called the 10.0.3.74. It has an application security group, and there's a machine here called NAT, and it has a NAT security group. Now this NAT security group must allow inbound connections coming from this, otherwise the traffic will not be allowed to go outside. This NAT security group needs to allow connections coming from applications security group on the new private. If you don't do that piece, we don't have it yet right now. We'll go to NAT security group and allow an inbound connection coming from the application security group, and then you can sit on the internal machine and get access to the world outside. So here is your security groups listing. Here is your NAT security group, and there you have inbound connections. There's only one. It says come from outside. I'll add another rule: allow all traffic as long as it is coming from applications, and save. Now that expands the scope of the NAT rule, which basically says yes, you will receive traffic except inbound traffic coming from, as long as it comes from the application side, you accept it. And then you are a NAT, so you will pass it on, you lie and you masquerade, and all that good stuff will happen. So let's go now see, we can test it. How do we see that? We'll first go to the NAT machine and we'll say ping 10.0.374. That should work. Yes, it is working. Nice. Exit. We'll now connect to SSH 10.0.374, and it just connects to the machine inside. Now here, can we update Ubuntu? This update Ubuntu will go to the Ubuntu update servers from the Ubuntu application server machine and try to update that box itself. Now can we succeed? Let's go find out. And it is doing it just like that. What is going through is going through the NAT machine, going to the world outside on these various addresses, ubuntu.com archive, and trying to update the box itself. And so that it fetched the apt cache. We can actually run the updates to apt upgrade, and it's going to update that Ubuntu machine. It's in the private area, and it is doing it. That is kind of sort of similar to you inside your home opening your iPhone browser or accessing CloudGenius website without actually connecting directly to the Comcast cable modem. That's exactly what's going on here right now. The Ubuntu box inside is going through the NAT box to go outside, and it should finish updates, and then we'll kill both the boxes, because that's the point, is to understand. And we have understood this. So as you will see, let me finish this update and I'll kill both the boxes, and then I'll summarize, and then we'll close for the stream for today. And so let's go begin the summary. So summary is like this. Here we go. So what did we do today? We understood various things: the public route table, the private route table. We also understand that this stupid Amazon doesn't allow you to create new machines in the 2D availability group for some reason. So when you create these public subnets and the private subnets, make sure that you don't select 2D, select 2A, B, or C, and then you create these subnets. You have to have a route table. The route table needs to be associated with the subnets. Then in the table, you have to have an entry for going anywhere within the VPC 16. It's a local connection already given to you. You have to create another route and use the gateway for the public side. Then you create a NAT machine here. Use the Amazon NAT image to create a new box. Put that here, and then change source destination check and disable or stop the source destination checking. Should be disabled for the NAT box. Then it becomes a NAT. Then you in the private side, you have to use the route table and expand it to allow it to go anywhere on the internet using the NAT device. It already has a local connection. Then you create a new machine here, and you are able to create security groups for this and security group for this, and this group allows inbound access from outside. This group allows inbound access from the NAT. This group allows access from the private side, and then we had this idea about SSH configuration, which is, by the way, that update finished. So we'll exit from that machine and we look at our SSH configuration. This is how it looks like. I'll pause a little bit here and make it bigger so you can copy paste, and actually the copy pasting will be available on the website. So this is a classic SSH configuration you should have. For a minimalistic configuration, you can expand it to make it comprehensive depending on how your needs evolved. But that's the SSH configuration we used. This configuration allows you to jump from your home or wherever you are to a intermediate stepping stone like a NAT or a Bastion host, or basically anything that you have as a foot in the door, stepping stone, and jump through that to the machines inside where you run your applications. This is just one of the simplest way to actually get through the firewall and get inside your public area, provided you have the private key. And never give out your private key, ever. There are more sophisticated ways of accomplishing these things, but we'll slowly build on. This is just the first way. Maybe the second way, because we have another way that I think we discussed in the past. But besides the point, this is one of the simplest ways of accomplishing it without compromising your security. With that said, let us go destroy the two boxes. The two boxes are the NAT box here. That machine needs to die, so we'll say you die, bye bye, and you also should die. So both the boxes are dead, and that's nice and clean, and they're shutting down, and they'll kill themselves, and the dead bodies will disappear in about an hour or so. Then that's the thing that we did today. Hands-on grunt work, lot of work, pretty boring if you are not into it. But most people that I see do this by hand actually enjoy this thing, and so that is something that the reason that I keep doing these exercises, so that help people understand. And if you understand, you will be able to accomplish whatever you want, and you will win. So if you get stuck, ping me. You know how to get to me. And so with that, I will disconnect the streaming, and the video will be available on our website, Cloud Genius website, and I will see you next time.